Hello, my name is John Lee, and I'm the president of Alpha Training and Consulting. And I have a true passion for preparing students for ASQ certification exams. However, today we're going to go over practice exam questions for the Six Sigma Yellow Belt exam. I'm taking those questions from the Quality Council of Indiana primer. We use this primer in our online class. We have you listen to all the lectures, take the exams, and we have you review the primer and take the end of chapter exam questions, which I lecture on, by the way. And that's what this video is going to be on, me lecturing on. I'm just going to take one or two questions out of each chapter to kind of give you an idea of the types of questions that you may see there. But anyway, Quality Council gave us permission to use those questions, which I'm greatly appreciative of. Great people over there, and we appreciate them. All right, like I say, we do have a class to prepare you for the Six Sigma Yellow Belt exam. And to learn more about that class, should you be interested, just go to ASQ CSSYB. That stands for Certified Six Sigma Yellow Belt. So ASQ Certified Six Sigma Yellow Belt.com, and you'll learn more about the Six Sigma Yellow Belt class, should you be interested. All right, let's go ahead and move forward now and work on those questions. So let's get started. The DPMO for a process is 8.60. What is the approximate Six Sigma level of the process? Is it 4.2 sigma, 4.4 sigma, 4.6 sigma, 4.8 sigma? That's what we have to determine. So what I'm going to do is I'm going to go to the primer back in the appendix, and we're going to look up this table that will give us that correct answer for this. So let's go and look at that real quick, and then we'll determine the correct answer. All right, here we are at the primer. And what we need to look up is the correct DPMO, which for this question is 860. And you're going to do this 1.5 sigma process shift side of the table. Notice there's no process shift over here. You don't want to use that one because it said the DPM for a process is 860. What is the approximate Six Sigma level? When they say Six Sigma, you have to take into account the 1.5 sigma shift. Now, if you need to look into this more, we have the 1.5 sigma shift lecture in Z statistic capability. But we're not going to go over that again right now, but if you need help on that, please go listen to that lecture again. So again, we're looking for 860, and we want to be in the 1.5 sigma process area here. So I go down, and I look for something close to 860. Notice 860 is between 4.6 and 4.7. And probably closer to 4.6. Okay, so it's either 4.6 or 4.7 will be the correct answer. Let's go back to those questions and see if we can find the correct answer. So here we are back at the colored pages, and there it is right there, 4.6. So we said it was either 4.6 or 4.7, so there we have it. 4.6 is the correct answer. Using Six Sigma methodology, a company at 4.5 sigma would have a failure rate of what? All right, we're going to go back to the appendix of the primer and use that same table we did with question 1. Only we're going to look up 4.5 sigmas, and we're going to see what the ppm level is of that. So let's go to the back of the primer and check that table out. All right, here we are in the appendix of the primer, and notice what they said here. I'm going to read it again. Using Six Sigma methodology, which means what? You have to use this 1.5 sigma process shift whenever it says Six Sigma methodology. So that's what we know right off. We have to use that 1.5 sigma shift. Using Six Sigma methodology, a company at 4.5 sigma would have a failure rate of what? So there we are at 4.5, 1,350 will be the correct answer. So let's go back to the yellow pages and make sure we can find that answer. So here we are back at the yellow pages here on question 5, and there it is, 1,350 parts per million. That is the correct answer. So hopefully you're good at using that table because you'll most certainly need it on the exam. All right, here we are at question 21, and it says a process consists of 3 sequential steps. Which of the following with the following yields? Step 1, 99.8%, step 2, 97.4%, step 3, 96.4%. Determine the total defects per unit. All right, so we need to go to the primer, find the formulas, and I need to also draw it out for you and show you how to solve this problem. It's not that bad, but you do have to know that when it says defects per, you have to go look up some formulas. So let's go to the whiteboard and work this one out. So here we are at the whiteboard. I've written everything down. There's our 99.8, 97.4, 9.964, 96.4%. And what you have to do to get the yield is you multiply all of those together. So as you see, I have the trusty calculator out here, and we're going to do that. 0.998 times 0.974 times 0.964 equals, and that gives me 0.937. So let's write that down. 0.9371 is approximately what we get there. So that is the yield, by the way. That equals yield, which we'll call equals Y. That's the yield. Now, we can convert this into defects. What did they ask for again? Defects per unit is what they asked for. So we have a formula that we can take yield and convert it into defects per unit. And it's not that hard. So let's go to the primer and show you where those formulas are, and then we can go forward from there. Okay, here we are in the primer, and notice what it says, defects per unit. That's exactly what we were looking for. And it says natural log of the yield. So we'll take the yield, take the natural log of it, and then use the negative sign. Because when you take natural log of yield, it's going to give you a negative sign. Take the negative, and negative makes it positive. And that's how you do this one. Remember, whenever it says defects per, you have to come to this page and find the proper formula. But for ours, it's pretty easy. The natural log, negative natural log, the negative of the natural log of the yield. We've already calculated the yield, so let's put in our calculators, hit natural log and negative, and hit the negative toggle, and we'll have this finished. Let's go back to the whiteboard and work this one out. So here we are back at the whiteboard. We already calculated the yield. Remember, we multiplied all those together to get the yield, overall yield. And now we're going to use the formula natural log of the yield, negative of the natural log. So let's get the calculator out. Here we go. We're going to go 0.9371. Natural log is right here. So we're going to hit that. And then, of course, we make it negative, which will make it positive. And the negative, by the way, let me move my calculator up here, is that toggle switch right there. So you have to hit that, and that will give you the correct answer. 0.06496, which is approximately 0.065, will be the correct answer for defects per unit. Let's go back to the colored page and make sure that's an option. So here we are back at the colored pages, and notice what we have here. The answer 0.065, which is exactly the one we calculated. So B is the correct answer for question 21. Question 1, the most difficult stage for any team to work through is what? When they talk about stages and teams, what are they talking about? Forming, storming, norming, performing. You need to know that very well, especially in this chapter. So which one do you think is the most difficult? Form, storm, norm, perform. If you think storm sounds like a difficult time, you're correct, and that is the correct answer is B. 3.2 here, question 2. If there are too many items for a team to work on, a positive technique to narrow the list is what? So you have this, I do this as a consultant sometimes. There's a problem, people are all busy trying to work on it, so I can't get everyone together, so I'll ask them, what are the variables that you think could be impacting this in a negative way? And every person will come up with this big list. I'll combine the list, get rid of any repeats, and I have a list. Then I go and say, would you vote on this to see, and vote 1 being the most important problem, and maybe I can only investigate 15. So I'll give them 1 through 15. I want to know the top 15. Then they'll vote on them, turn them in. I'll take an average of everything or sum up the votes and get my top 15. And that's what I mean by taking a list, sometimes there are over 100 variables, I get it down to 15. And how do I do that? That's what they're talking about here. If there are too many items for a team to work on, a positive technique to narrow the list is storming, no. Optimizing, no. Voting, yeah, it'll have the word voting because that's what they did. They voted on the top ones. Multi-voting, many people voting. Norming, it's multi-voting. Now, you could do that with logic and say, oh, I see, we're going to have to vote. This has vote in it. That's the correct answer. You get it right. Or it could also be a lookup problem because there is actually a technique called multi-voting. And I have a lecture on that, so hopefully you listened to that. And if you did, this would be a very easy one for you. But the correct answer is definitely C. All right, goodbye. Studies have shown that the most effective method to communicate information is oral, written, nonverbal, a combination of both methods. Yes, it's going to be a combination of methods. Remember, ASQ would rather have more communication than less, and a combination means more communication. So 4.3, no doubt, is D to success. 411, the critical path in a project means that the project is important to the profits of the organization. No, this is a vocabulary question. So again, could you look this one up? Yes. A lot of these are lookup ones in this section. The project isn't, okay, we decided to throw A is out of there. Slack times can be used to delay the ending date of the project. No, that's not a definition of critical path. Delays of the events on this path delay the ending date of the project. That's the correct answer. That is the definition of critical path, is C. Activities cannot be crashed. No, activities on the critical path should be crashed, but it doesn't answer the question there. So the correct answer here is no doubt C. This is another one that you could have looked up if need be. Now, question 4, consider the following data set, and you have all these numbers. Which of the following data are factual statements regarding this data? Then it talks about means, modes, medians. So let's go to the whiteboard and calculate the mean, median, and mode. And once we have that, we can answer this correctly. But let's go to the whiteboard and help you out with this one. All right, here we are at the whiteboard. I wrote down all the numbers. I counted to see how many numbers. Notice I have 8 numbers. So it's not an odd number. So to get the median, we'll have to take the 2 middle ones, which means there will be 3 on each side, 2 in the middle. And so 7 and 8 will be the middle ones. So I'm going to circle those. So we'll have to take the average of the 2 middle numbers to get the median. But let's do the mean. Let's not get ahead of ourselves. And to do that, you should use a calculator. So I'm going to pull out my trusty calculator. And I'm going to calculate the average. The way you do that on this calculator is you put in the 3, hit that summation sign right there. That puts it into memory. 3, 4, then every time I hit that summation sign, 7, 7, 8, 11, 12, 13. Okay, and I put 8 of them in there. There is 8. See, n equals 8. So we know we at least got the right number of numbers in there. Now what I'm going to do is I'm going to hit second function, and I'm going to hit average, and that will give me the mean. So second function and average, which is right above the x squared button. That's why I had to hit the green button, because this is green. So second function, average. Average is 8.125, or the mean. Mean and average are the same thing, 8.125. Then the median, remember, is the middle number, but if we have even number sample size, it's the average of the 2. Notice there's 3 on each side, so this is the median, is the average of 7 and 8. So I'll go ahead and do that. 7, 8, put that in my calculator. Second function, average is 7.5. Many of you could have done that in your head. That's okay. 7.5. And the mode is the most frequently occurring number. Well, which number takes place? They all only take place once, except 7 takes place twice. So 7 is the mode. It's the most frequently occurring number. And So we'll put 7 there. So what do we know? We know that the mean is greater than the median, and the median is greater than the mode. And so with that being said, let's go back to the answer options and see if we can pick the right one. So here we are at question 4, and we took that data. Which of the following are factual statements? The mean is greater than the mode. That is true. So that's going to be our correct answer. The median is less than the mode. No, that's not true. The mean is less than the median. No, that wasn't true. The mode and the median are the same. No, that was not true. The only one here that is true is A. So hopefully that helped you, but A is the correct answer for question 4. The repeatability of an R&R study is most similar to what? Okay, what does R&R stand for? Repeatability, reproducibility. What is repeatability? It's also called precision. It's also called sigma of the measurement system or the measurement instrument. Okay, and if it was reproducibility, another word for reproducibility is reliability. So keep that in mind. But they don't usually test on that, but they always test on repeatability. What else is it called? Precision. The repeatability of an R&R study is most similar to the precision of the measurements. That's correct. Precision, repeatability, same thing. A determination of gauge sensitivity, no, that's instrument resolution. The gauge reproducibility, no, that's reliability. The accuracy of a number of measurements, that's bias. Okay, so the only one that is related to repeatability here is A, and A is the correct answer on this one. All right, here we are on question 4. When the natural process limits, okay, that's the first thing you need to understand, are what are natural process limits. Since it says process, it means the natural process limits are 3 standard deviations away from the average of the distribution. So remember that. Natural process limits, 3 standard deviations away from the process average. So when the natural process limits are greater than the specification range, which of the following courses of action involves the customer? So first I'm going to the whiteboard and explain this, draw it out so to make sure you understand it. So let's go to the whiteboard, then we'll continue on with this question. All right, so here we are at the whiteboard, and notice I've drawn out the distribution, the normal distribution there, and I'm going to read this again. And says, when the natural process limits, okay, what are the natural process limits? They're 3 sigmas from the average. That width of the curve is called the natural process limits. Now, the next part of the question says, when the natural process limits are greater than the specification range, okay, they're greater, which means the specification range is inside here because the natural process limits are greater. So we'll call this the upper spec limit, and this is the lower spec limit. And this is called the specification range. Specification range. There you go. So this is what the question says. When the natural process limits, plus minus 3 sigma, are greater than the specification range, what does that mean? Well, let's read through the options and decide. I'm going to read it one more time, and you look at that picture, make sure you know what we're talking about here. When the natural process limits, plus minus 3 sigma, are greater than the specification range, which they are here, which of the following courses of action involves the customer? Change the specifications. So let's move the specifications out. So the specification range is greater than the natural process limits. That's what we'd rather have. That way we don't have that much scrap. See, anything above the spec limit, above the upper spec limit, or below the lower spec limit is scrap. It means money. You're throwing away money, and we don't like to do that. So we'd rather have the specification range be wider than the natural process limits. So that would be nice, and you could move the specs. However, if you move the specs, you probably better let the customer know, because spec limits either come from customers or engineers, and so you need to make sure and run that through the customer. So I can almost guarantee you that's going to be the correct answer. Centering the process? No, I've already shown it pretty centered here, but let's say this average was not centered between the spec limits, you could center it. Customer doesn't care. Just makes it perform better, less scrap. Why not? But you don't have to ask permission for that. Reducing the variability. You could reduce, by reducing the variability, the natural process limits will come in. Okay, they will come in. So I'll draw another line there. If you reduce variation, you could reduce variation, let's say right here by this dotted line. And if you reduce variation, reduce the width of that curve, then of course the natural process limits would be less than the specification range, which is what we want. So you could do that. The customer isn't going to say anything. They're just going to be happier because you're not sending as much scrap to them. So that's a good thing. Okay, so we don't need to worry about that one. Accepting the losses. Yes, you could inspect out all the bad parts, assuming you could. Probably can't. They say 100% inspection is only 85% effective. So that's not a very good strategy to begin with. But so let's look through that again. When natural process limits are greater than the specification range, which of the following courses of action involves the customer? Just A, changing the specifications. Let's go back to the yellow pages and review this real quick and move on to the next question. So here we are back at the yellow pages, and again there we have it. When the natural process limits are greater than the specification range, which of the following course of action involves the customer? Change the specifications will require customer notification. 6.5, in a simple two-variable linear regression study, what does the term beta 1 represent? Well, I'm going to go to the whiteboard, write down the symbology for linear regression, and then we will determine what the correct answer is. All right, here we are at the whiteboard, and I've written down an equation for a two-variable. I'm assuming that's what they're talking about, is two independent variables. So y is the dependent, these are the dependents, and beta naught, remember this, because sometimes they test on you on this. This is the y-intercept. So y equals beta naught. How do you know this is the y-intercept? Because it's not multiplied by x, which is the independent variable. Notice this is multiplied by x. This one is multiplied by x. So these are the independent variables, the x's. And that's the slope for this x. This is a slope for this x. When there's more than one slope, they just call it a coefficient. This is the coefficient 1 times x1, coefficient 2 times x2. So here's the whole equation. Y, the dependent variable, equals beta naught, y-intercept, plus beta 1, coefficient 1, times x1 plus coefficient 2 times x2 plus any error that may take place there. So that's the common symbology used in linear regression analysis. Now that you know that, let's read through this, see if you can answer it. In a simple two-variable, linear regression study, what does the term beta 1 mean? Now, they did put, I better finish the symbology, they put kind of an upside down V, we call it a caret. Caret usually means an estimate of, so you don't have to put that there, but they put it here, and that's okay. And so with that being said, what does the term beta 1 represent? The slope of the line could be the x-axis intercept. No, that's beta naught. The measurement of the interaction? No, there's no interaction term here. If there's an interaction term, you'd have to go beta 3 plus beta 3 x1 times x2. You'd have to multiply more than one x together, you see. That would be an interaction. So that's not correct. The y-axis intercept, no. That would be the y-axis intercept right there. The other one said x-axis intercept, and we don't use that in here. So the only one that could possibly be correct here is the slope of the line. This is the slope for that variable. So let's go back to the yellow pages and check this out one last time. All right, here we are back at the yellow pages in the primer, and it's 6.5 says, in a simple two-variable linear regression study, what does the term beta 1 represent? There it is, the slope of the line. A small positive change truly exists between a test trial and the current process. Okay? So something really did change in the process. It's statistically significantly I'm sorry, statistically significant difference. A small positive change truly exists between a test trial and the current process. However, the sample from the test trial happens to demonstrate a radical improvement. Okay, so it was just a small change, but your test said there was a big change. Well, these tests are not designed to tell you if it's a big change or a little change. It's just designed to tell you, is the change statistically significant? So I'm going to read it again. A small positive change truly exists between a test trial and a current process. Okay, so it is statistically significant. However, the sample from the test trial happens to demonstrate radical improvement. Doesn't matter. It was different, and the test said it was different. So it was a correct action. What type of decision would probably be made? Well, first of all, it is a correct decision because something did change. We said it did change. So let's go to the primer. There's a little table there that will help us answer this question rather easily. But first of all, I must say that when you make the correct decision, it's 1 minus. Okay, 1 minus alpha or 1 minus beta. Both of those mean you made the correct decision. Alpha or beta means you made the incorrect decision. So 1 minus means you made the correct decision. There was a correct decision made here. And so it's going to be either 1 minus alpha or 1 minus beta, I can tell you that. Which, just knowing that, gets your odds to 50%, which is better than our original odds of 25%. But we can definitely get this one correct. Let's go to the whiteboard and look at that table from the primer. So here we are in the primer, and let's look at this. First of all, you must understand that the null hypothesis means equal. So did things remain equal? Or no, they did not remain equal. So null hypothesis means equal. It's true, it's equal. No, they're not equal. There was a change taking place that put you in this column. So let me read and see which one we're supposed to go to. A small positive change truly exists. A change does exist. Okay, then the null hypothesis, which says they're equal, is false. So we have to go down here, and it's either going to be beta or 1 minus beta. But we know what? That it's 1 minus beta means it's correct. And in this question does say we're correct, so it's going to be 1 minus beta. But I'm going to read through this anyway, and you can look through this while I read it. A small positive change truly exists between a test trial and the current process. However, the sample from the test trial happens to demonstrate radical improvement. I don't care. The test was not designed to determine how big the change is. It's just used to determine if statistical significance exists. Okay, if a difference exists. What type of decision would probably be made? So yes, there is a change. Remember, null means equal. Is it equal? No. Then equal is false. Yes, it is false. There was a small change, they said, in reality. And that your test said that there was a change. Reject the null hypothesis. Reject equals. And you may have to go back and study null hypothesis and all that too. If not, you could be a little bit confused here. Remember, false means not equal. And in reality, it was not equal. And your test, reject H not, you may write in parentheses there, not equal. So it was, in reality, it was not equal. You said it was not equal. That's 1 minus beta, which is 1 minus beta decision is D. So we'll go back and read that again. But again, you could make some parentheses here to make this easier for you, perhaps, if you struggle with the term null hypothesis. So null hypothesis means equal. It is equal. It is not equal. So put not equal here, equal here. The question said it was not equal, so we're working with this. And it said in reality it was not equal, and your test said it was not equal. Put not equal here and equal there. That's not perfectly the way to do it, but it'll get you through the test. So equal. So you said it was equal. In reality it was equal, or not equal. You said it was not equal. The test said it was not equal. There we go. That's 1 minus beta. Let's return to the yellow pages and review this real quick. So here we are back at the yellow pages, and there it is. A 1 minus beta decision is the correct one, and that's answer D. 7.1, the major differences between Kaizen and Kaizen Blitz activity is what? Well, Kaizen Blitz is supposed to be finished, generally speaking, between 3 and 5 days. Every organization may have their own time frame, but it's a shorter time frame and a defined time frame, where Kaizen probably has no time frame set on it. You could say time spec limits, if you will. 3 to 5 days is normal again. So what is it? The number of people involved, not necessarily money, no, time, there it is. We knew that was the correct answer, and that is the correct answer for 7.1. And D, the availability of data, no, C is the correct answer for question 1. 7.9, an X bar R chart has been in control for some time. Very good. It's in control, it's predictable. If the range suddenly and significantly increases, the mean will do what? So the width of the distribution, boom, it goes out big time. But what does that mean concerning the mean? Well, usually increase, could decrease, I don't know. Stay the same, maybe, but the odds of it staying the same or increasing are probably equal. Always decrease. I wouldn't choose always because it's an absolute and I have this non-absolute to choose from. It's not going to stay the exact same, so that's not a good one. So if I had to choose between A, B, and C, I would choose A just because it's not an absolute. Okay, but I don't think it's going to be A, B, or C. I think it's probably going to be D. Occasionally show out of control of either limit. Yes, so it'll occasionally go outside the control limits. Why? Because the distribution has all of a sudden become much wider. So here are your control limits. The distribution has become much wider, and therefore you have more chances of going outside the control limits. So this one, no doubt, the answer to 9 is D. 12 here, an X bar control chart is based on a sample size of 4. An operator mistakenly plots the value of the single observation on the control chart. This point means what? Well, this is a very tricky one. Okay, why? Because the control chart was designed for a sample size of 4. And the operator just plots 1, gets a sample size of 1. He's supposed to get a sample size of 4. What does that do to the distribution when you use 1? The distribution of sample size of 1 is much wider than the distribution of a sample size of 4 per the central limit theorem. So that number 1, they're not using the chart correctly. However, and this is the difficult part, an operator mistakenly plots the value of the single observation on the control chart. Oh, okay. No, this isn't overly tricky. I thought it said something about range, but I misinterpreted that. So yeah, they're misusing the chart. Will not cause any misjudgments. It most certainly will, because you just made the distribution much wider. Will always be plotted near the center? No. Will cause the associated R chart to show out of control condition? No. First of all, how are you going to get a range from a single point? That's a problem. Increases the probability of the process being labeled out of control? Yes, that's what it would do, because it increases the width of the curve compared to the sample size of 4. So D is definitely the correct answer for question 12. All right, question 30. A process is checked at random by inspection of samples of 4 shafts after a polishing operation. The X bar and R charts are maintained. A person making a spot check measures how many shafts? 2. And what was the chart designed for? 4. So they have already made a mistake. 2 shafts accurately, and plots their range on the R chart. Okay? The point falls just outside the control limit. Okay, this is a tricky one. He or she advises the department foreman to stop the process. This decision indicates that, well, first of all, they misused the chart. However, if you have 2 points and you take the range and it's outside the control limit, the range is not going to get any smaller. The range is not going to get any smaller if you add 2 more values to that range. Could get higher, but it's not going to get lower. Because remember what range is? Highest minus lowest. And of these 2, highest minus lowest, I'm already outside the control limits. It's a very tricky question. The process level is out of control. Maybe. Depends on what they mean by process level. Process level is out of control, but not the dispersion. Okay, so they're saying process level is the average and range is the dispersion. So if that's the case, we're not talking about the process level, we're talking about dispersion. The person is misusing the chart, that's true. The process dispersion is out of control, that's also true, but it says this decision indicates that. It is misused, but it doesn't matter because you're going to be outside the control limit either way. So you know the process dispersion is out of control. This is another tough question, but the correct answer is D. All right, congratulations. I hope you learned something from looking over those exam questions and looking at the lecture. If you need any help, let me know. As you can see, I've passed a lot of ASQ certification exams, and I can most certainly help you. If you have any questions, please contact me through my website at alphatc.com. Go to the Contact Us option, send me a message. I'll get back with you as soon as possible. Thank you, and have a great day. Goodbye.